Assalamualaikum and hello guys, we are students from University Technical Malaysia Melaka, UTeM, and in this episode we'll be sharing to you about an assignment that we conduct for our static subject. In our group, there are consists of 4 beautiful ladies that will assist you in this episode. After a few days of discussion, we managed to achieve an agreement to use crane as our subject. I forgot to tell you, we are from the MMV S2/1. So let's get started. Okay. Hello. Okay, in this part, I will show to you about the real image of this crane that we choose. You can zoom in. Okay, thank you. Unfortunately, we are not calculating for all this part of crane, but instead we are focusing on this beam. So, from this beam, we translated it into an FBD. From this FBD, you can see the values in here. All these values, we are used an assumption.
Hi guys, my name is Fatin Fahana and I'm going to explain to you the forces at point A. Now, let's refocus the forces at point A. So, we enlarge the free body diagram at point A. We can see that at point A, we have an angle at 45 degree and 22 degree. And then, we find another angle by subtracting the both 45 degree and 22 degree to get an angle of 22 degree. And then, after that, we resolve the equation at point A by using the formula of fx and fy, and then we will get the result.
Hi, I'm Marlisa. So for today, I would like to explain about the forces at point B. Okay, so in my part, I will discuss about the forces at point B. So as you can see, there is a load hanging at this point, and which is 6,250 Newton. So if we draw the y-axis, we will get the angle between the load and the y-axis is 45 degree. So the forces at y-axis is equal to 6,250 cos 45 degree. Then we get 4,419.42 Newton. Okay, next for the forces at x-axis is equal to 6,250 sin 45. So the answer is 4,419.42 Newton.
Assalamualaikum. Hi, my name is Nafara Fariza binti Ahmad and today I'm going to discuss to you about center of gravity at point C. So, in my part, I'm going to explain to you about the center of gravity at point C. As we can see, the total force of this beam is 10,000 Newton. So, at point center gravity, as we can see, the angle is 45 degrees. So, the summation of y is 10,000 cos 45 degrees. So, total we can get 7,071.06 Newton. You can see the summation of x is 10,000 sin 45 and we will get 7,071.07.
Hello, we meet again guys. First of all, you don't even know my name, right? My name is Nur Akila binti Muhammad Nizam, and for my part, I will explain to you about the equilibrium equation. Okay, you have spent your time with 3 beautiful ladies that explain to you about the FBD. And now from this FBD, we are extracting all the information from this FBD to make an equilibrium equation. Okay, first of all, we have to state that summation of fx is equal to 0, and then we include all the information from x-axis into this formula, and then it's equal to 0. Next, summation of fy. We are using the same technique, which is including all the point from y-axis and then make it equal to 0. Lastly, summation of moment. As we know, moment is the product of force with distance, and we include all the data and make it equal to zeros.
Okay, based on our explanation, So we can conclude that cranes are commonly used to lift extremely heavy objects. As the crane at the equilibrium, crane's beam is balanced at the fulcrum. By applying small force, we can lift heavy objects with the presence of lever. And the top part of the crane, called the most, are used to raise building materials.
That's all from us. Bye!